Okay, so in this screencast, we hope to explain to future elementary educators with some more examples what equivalent fractions are all about. So consider the following. How do we know if two fractions are equal? Are 12/20ths and 21/35ths equal? Pause if you need to. Think for a moment. Are those fractions equal? And how do you know? Well, there's a couple of ways we could figure it out. We could simplify the fractions. And what does that mean? Well, that means that 12/20ths, well, 12 is 3 times 4, and 20 is 5 times 4. So the times 4s, that's a common factor in numerator and denominator. And so those can cancel, and you're left with 3/5. Similarly, 21/35ths, well, 21 is 3 times 7, and 35 is 5 times 7. Both of those have a factor of 7, and so that fraction is also 3/5. So we can say, yes, those fractions are equal. But we could also take a look at getting them a common denominator. To get them a common denominator, it's a very visual thing. So this is some whole that's been broken up into 20 pieces, and this is some whole that's been broken up into 35 pieces. When we get a common denominator, we're getting equal pieces to look at. So we consider what a common denominator might be for 20 and 35. That's the least common multiple of 20 and 35, which happens to be 140. And what does that mean? It means we're going to take each of the pieces here and break them up into 4 more pieces each. We're going to take each of the pieces here and divide those pieces into 7 little pieces each, so that there are 140 pieces here and 140 pieces here. 12/20ths is how many 140ths? Well, if we took the pieces down here and broke them up into 7 little pieces each, then each of the 12 we chose also broke up into 7 little pieces each. There are 84 little pieces. Similarly, 21/35ths, how many 140ths is that? Well, we took each of the little pieces and we broke them up into 4 little pieces to get from 35 to 140. So the 21 we chose also got broken up into 4 little pieces each. There are 84 pieces out of 140. So if we simplify the fractions, we see that the fractions are equal. If we get a common denominator, we get that the fractions are equal. These are both valid ways for us to work on things. You may recall, here's a side note, you may recall that A over B is equal to C over D if A times D is B times C. This was a thing you learned in middle school called cross multiplication. Question, which is bigger, 1/3 or 1/4? And how do you know? Better yet, how do you explain to a small child which is bigger, 1/3 or 1/4? Well, I think 1/3 is bigger. We could explain it to a small child with the blocks. 1/3 certainly appears to be bigger than 1/4. Is there a reason why? Sure. In this case, the 1 got broken up into 3 pieces. In this, the 1 got broken up into 4 pieces. So if you take the same size whole unit and break it up into more pieces, each of those pieces is smaller. So Since we're only choosing one piece here and one piece here, we can look at the size of the pieces we've broken things up into to determine who's bigger. If we only break up into 3 pieces, those 3 pieces are bigger. Well, which is bigger, 2/5 or 3/5? Well, 3/5 is bigger. How do you know? In this case, the size of the pieces are the same. So if the size of the pieces are the same, we choose the fraction that chooses more of those pieces. 3/5 is bigger than 2/5. We can compare them, and pretty easily, because they have the same denominator. So which is bigger, 3/7 or 4/9? It's remarkably close, by the way. Well, let's go orange. So we could do this cross multiplication thing that we've been doing. 3 times 9 is 27. 4 times 7 is 28. 3 times 9, 4 times, like we could do that, but what does that mean? And who says what about whom? Well, it turns out that the 4/9 is bigger if the 4 times 7 is bigger than the 3 times 9. How can we know that? Well, we can get a common denominator. 3/7 is equal to some number of 63rds, and 4/9 is equal to some number of 63rds. Why 63? Because that's the least common multiple of 7 and 9. So if each of the 7 pieces gets broken up into 9 each, then the 3 pieces we chose also get broken up into 9 each. If each of the pieces here gets broken up into 7 pieces each, then the 4 we chose get broken up into 7 pieces each. So 28/63 is bigger than 27/63, and that's what this shortcut that you may have seen represents. But this is what's really going on, and you, as a future teacher, have to know what's going on. So last activity for our lesson. Take a piece of paper, any piece of paper, some piece of paper, any piece of paper, like so. Pretend for the moment that that piece of paper is 2/3 of some whole. Model what 1/6 of that same whole would be. And then think about how you would explain that to a small child. So this piece of paper is 2/3 of some whole that we don't see. What would 1/6 of that same whole be? Well, I hope it's pretty straightforward to say that if we split the paper in half, that what's over here is 1/3 of the whole, and what's over here is also 1/3 of the whole. We don't want 1/3, we want 1/6. How does 1/3 relate to 1/6? Well, 1/3 is 2/6, it's twice as big. So what's 1/6? 1/6 is half of the 1/3. So that part right there is 1/6 of the whole. 1/4 of the paper is 1/6 of the whole. And that's how I'd explain it to a small child. I'd fold the paper twice. Hopefully some of this is helpful. I do sincerely hope that, and I will see you soon, I hope.